Simulation principles, section 3, part 2. So here we have an example, which is a dump truck problem. Here we have 6 dump trucks, which are used to haul coal from the entrance of a small mine to the railroad. So we have the trucks, they may wait in line to be loaded here. Okay, to be loaded here. So we have 2 loaders here. As you see in loading the station, we have two loaders. So the trucks are loaded by these 2 loaders, and then they move to the scale. So they may wait in the line to be weighed by scale. So after waiting, they have travel to unload the coal and then travel back to the loading station at the end. Okay, so this is our system. We have 6 dump trucks, and we would like to actually simulate the system in order to estimate the loader and scale utilizations. Okay, so let's start modeling the system by static description. At first, state variables. So here we have 4 state variables, one for the number of trucks waiting for loading, and then one for the loading status, the number of trucks being loaded could be 0, 1, or 2, and the number of trucks waiting in the scale waiting line, and WT, the number of trucks being weighed, it could be 0 or 1. So we have 4 state variables here. Okay, and for entities, here we have just 6 dump trucks, right? So yeah, not more than that. We have just 6 dump trucks. Okay, and for the events, we have arrival event at loader queue. So we show this by ALQ, and then departure of departure from the loading station. So we show this by EL, end of loading, and end of weighing, which is departure from scale station. Okay. For the event notices, we have the arrival at loader station ALQ at time T for dump truck T DTI, and same as this one, the end of loading and end of weighing. Okay. So for the list here, we have 2 lists, one for the loader queue and one for the weigh queue. Okay, and for activities, we have loading time, we have weighing time, and also travel time. So we have 3 activities here, one for loading, one for weighing, and one for travel time. Okay, so as you see here, there is no inter-arrival time, right? Because we don't have that one here. Somehow the interval time is somehow travel time, right? Okay. And the delay at loader queue and delay at weigh queue. So we have 2 delays here. Okay. So let's solve the dynamic description. At first, we need to obtain how we are going to estimate the time, the duration time for the activities. So here we have 3 activities: loading time, weighing time, and travel time. So we assume that based on the historical data, we can obtain these distributions for these 3 activities. Okay. In dynamic description, we need to obtain the initial status. So here we define the initial status for this system, that one dump truck is at the scale ready to weigh at time 0. 2 dump trucks are at loaders ready to be loaded at time 0, and 3 dump trucks are at the loader queue. Okay, so waiting to be loaded. So this is our initial status. Okay, and here we assume that we have generated the time duration for the 3 activities, like these numbers, by the distributions. Okay, so this is for the manual simulation. So let's have the logic for the event. This is for the arrival at loader event. So at first we check the loading station status. If LT equals 2, this means that both two loaders are busy. So if yes, we go to step 2, else we go to step 3. In step 2, actually we add the number of dump trucks waiting in line by 1, and we append the ith dump truck to the list, to the list of the waiting. Okay, and then we go to step 4. At step 3, this means that at least one loader is empty, is idle. So the number of dump trucks being loaded will be added by 1 here. And since one activity has started right now, so we need to obtain a departure event for that. So end of loading at time t plus lt will be scheduled. Okay, and then we collect statistics and update counters. For the end of loading event, that's a departure type event. So here, let me show you here. Actually, we have the loading station, right? And then we have a scale. Okay, so when a departure occurs from loading station, so here we need to check if there is some dump trucks waiting in the line for the loading. Then we need to actually have one dump truck to be loaded here, and then obtain a departure event for that service. And for here, since we have a departure from loading, it has to go to scale, right? So here again, we need to check if the scale is idle, or if there is a line here, then we need, so this dump truck will be added to that line as well. So here we need to check two things. One, here, the loader queue status, and one here, the scale waiting status. Okay, so as you see here, at first we subtract the number of loaders being busy by 1, and then we check, this is the first part, here. So we check the queue status of the loading. So if it's greater than 0, so we subtract this by 1, and then we add 1 to the loaders being busy. So we remove the dump truck from the first place of the list, yes, and again we need to obtain a departure even here for the end of loading for that dump truck. Okay, and this is the second part here. We check the scale status. If WT is 0, then we set it to be busy, and we have a departure event here for end of weighing at time t plus WT, and then we go to step 5. Okay, so in step 5, sorry, we go to step 6 here, but in step 5 is the case that the scale is busy, so we just add up the number of dump trucks waiting in the line for scale and append dt dump truck I to the end of the list. Okay, and that's it. We collect the statistics and update the counters at the end. Okay, the end of weighing event, so it's a departure from the scale. So here we have the scale and we have a departure, right? So this departure of the dump truck, it unloads, and then after unloading, it gets back to the loading station, right? To the loading station. So here we need to check two things. At first, since it's the departure and it goes to the loading station, so we need to obtain an ALQ event. So this means that an arrival event to the loader. So we have a travel time here, right? Travel time here. And so based on that travel time, the arrival event will be scheduled for the loading station. And also we need to check the waiting line for scale, if it's positive, I mean there's some dump truck waiting line, so we need to actually schedule a departure event for serving the first dump truck in the line, and that's it. Okay, so here we have, at first we set the status of the scale to be idle, and then we schedule the arrival to the loader at time t plus tt based on the travel time, and then we check the status of the waiting line for a scale, and if it's positive, so we subtract the number of dump trucks waiting in line, and then we change the status of the scale to be busy of serving that dump truck, and then we remove that dump truck from the list and schedule the end of weighing event at time t plus wt. Okay, and that's it. Okay, and so for the statistics at the end, we need to obtain the total utilization rate, let's say, for the loader and for the scale. Okay, let's simulate this example with sample data that we have here for loading time, weighing time, and travel time. Okay, so at time 0 for the initial status, as you remember, we have 3 trucks waiting in the loading station. 2 trucks are ready to be loaded, so at time 0 loading of these 2 trucks will be started, and 1 truck at the scale. Okay, so for the list, as you see here, we have dump truck 4, 5, and 6 waiting in the loading queue, and the feature event list, as you see here, we have the loading time 10 and 5. So for dump truck 3 it takes 5 minutes, for dump truck 2 it takes 10 minutes, and the end of weighing for the first one it's 12 minutes, right? So the end of weighing will be for dump truck 1 at time 12. So as you see here, the next event will be end of loading of dump truck 3 at time 5. So time jumps from 0 to 5. So we have the end of loading event for dump truck 3 at time 5. So since it's end of loading, so one of the loaders waiting in line will be join that loader. So the number of trucks in line will be reduced from 3 to 2, and still LT is 2. I mean, both loaders are busy, and since a scale is busy, so this dump truck and dump truck number 3, I mean, will be in the line for a scale. Okay, and WT is 1 as well. So yeah, and LSW key, I mean, the list for a scale includes dump truck 3. Okay, so again here we have the end of loading at time 10 for dump truck 2, and here we have end of loading at time 10 for dump truck 4, and end of weighing for dump truck 1 will be at time 12. Okay, so here we are at time 5. We have 2 loaders, and both loaders are busy, right? So 2 times 5 will be 10 minutes. This means so far the total uptime for the loaders is 10 minutes. Okay, and same for the scale, it's just 5 minutes. Okay, so we go to time 10. Again, there's another end of loading here for dump truck 2. So the number of dump trucks waiting in line for loading station drops to 1, and still nothing changed for the number of trucks being loaded, but the number of trucks waiting in line for scale increases to 2. Okay, and yeah, so as you see here, just dump truck 6 is in line for loading, and 2 dump trucks 2 and 3 are in the scale line. So as you see here, so we have again end of loading for dump truck 4 at time 10, end of loading for dump truck 1 at time 12, and end of loading for dump truck 5 is scheduled at time 20, right? So it's current time is 10, then the loading time is 10 for this track, so it will be actually 20. Okay, so we are at time 10, and again it's a cumulative, so the previous time was 10 plus 2 times 10 minus 5, so both loaders were busy during this 5 minutes, so in total it's 20 minutes as the uptime for the loaders, and same for the scale. Okay, so yeah, and with the same manner we continue simulating the system by hand for the rest of the times. So we go ahead and ahead, and at the end you see that the average loader utilization is this. So 49. So as you see here, the total simulation clock is 76, right? So if we multiply 2 by 76, this will be the total time for the two loaders. But the total uptime for the two loaders is 49. So if we divide 49 by this number, this means the average loader utilization is 32%. And same for the scale, as you see here, for the scale BS is 76, so this means a scale was busy all the time during the simulation. So it's 100% actual as utilization rate for the scale. Okay.